Hi, my name is Noelle, and my team members Taryn and Brian and I will be going over our project on the design of an improved process for man lifts for Webcor Concrete. Our technical advisor is Dr. Wang, and our administrative advisor is Dr. Macedo. So our agenda today will just be covering the background, the problem statement, and then we'll move on to the design and methods and end with our results. So Webcor Concrete is a commercial construction contractor with about 1,000 employees. Their headquarters are up in San Francisco, but they have sites all throughout California. Specifically, Webcor Concrete comes in to just build the concrete structure of the buildings. They have a standardized 3-day concrete cycle per floor, and specifically when we went up to visit their job site, we looked at their project at Trans Bay Block 8, which is a 55-story residential living building. So a little background on this project: in addition to doing the concrete for the building, Webcor is also the general contractor. So they subcontract out the man lifts, and the man lift is basically just used to move workers between floors of the building. And as the building is built up, the man lift is also built up to reach the top of the floor. So our problem statement is focused on the man lift and the wait times employees experience in order to get to their work area. Because man lifts are the only transportation available to employees to get to their workspace on high-rise buildings, there is often wait times that delay workers on the job site. Alright, so moving on, we're going to discuss the steps in our design of a solution and the methods of testing these possible solutions. Alright, so we're going to start by describing the current state of the man lift process for Webcor. So currently the lift starts at the ground floor and the passengers load onto it, and the door is then closed behind them. At that point, the operator determines what floors are needed to stop at, and he will then move to the first floor, or the first stop. Then the door is opened and the passengers load and unload as needed. After that, the door is closed and the operator determines if more stops are needed. If more stops are needed, then this process is repeated with every additional passenger. And if more stops are not needed, then the operator will switch direction and return to the ground floor, which then ends the man lift process. The current process is a low quality one because the current standard operating procedure is not extensive, standardized, or sustained in any way. This presents opportunity for productivity improvements on the job site because of the long times employees have to wait for the lift. And we'll discuss about cost estimates for the current state later in this presentation. Alright, so we began by making a fishbone diagram to describe our thought process and how we decided on what factors to focus on. The problem that you can see in this diagram is the waste from employees waiting for the man lift, and all the possible causes are shown on the diagram grouped in their respective categories, so personnel, method, environment, machine, and materials. And the causes that we chose to focus on were lack of an enforced standard operating procedure, operators, and number of lifts. Most of the other factors, such as loud atmosphere and lift capacity, are out of our control. Alright, so moving on to some of our ideas for improvements to the current system, we're going to start with standard operating procedures. So as was already stated, Webcor currently has a loose set of standard operating procedures for the man lift operators, but they are not a strict set of procedures and are not enforced. So we came up with a few ideas for a more strict set of SOPs. So starting off, we're going to start with the door opener / closer, and as you can see from the picture on the right, every time the man lift starts or stops, the door needs to either be slid open or slid closed. And currently anyone can close the door, and it is the operator's responsibility to make sure that the door is shut before they start moving the lift. So a better method would be to have a set person who is supposed to open or close the door, whether it be the operator or one of the passengers, just so it's not switching around every time and that it is a more consistent process. After that, we think that passengers should keep in mind the man lift efficiency. So for example, if they need floor 16, they could get off at floor 15. Currently, it takes about 5 seconds for employees to climb the ladder in between each floor. And while it does only take about 2.5 seconds for the man lift to ascend one floor, if unloading and loading times are included, then it takes closer to 30 seconds each floor that the man lift stops at. So getting off at an earlier floor and climbing up the ladder could save a lot of time in the process. And we believe that within 2 floors is a reasonable thing to ask of employees without overtiring them from climbing the ladder too much. And this would be a way to improve the efficiency of the lift because it is not stopping at as many floors. After that, another part of the SOP would be communication between operators. So for example, after someone radios for a man lift, the operator who is going to get them and who is in a good position to go pick them up can speak into the radio to let everyone know they're coming, just to avoid 2 operators going to the same stop to get the same passenger, which would waste even more time. And then after that, another thing we added to the SOP was after about 3 minutes of waiting, employees should radio again. And now moving on to how we applied 6S to the current man lift state. So starting off for sort, we want to continue with the use of the whiteboard that Webcor currently has in their man lifts, which you can see from the picture on the right. But with the whiteboard, implement a more specific system that all the operators can easily follow, rather than operators choosing whether or not they want to jot down the floors that are needed onto the whiteboard. Also, part of SORT is the use of radio, and the operator is not only communicating with passengers, but also communicating with other operators to ensure that multiple operators don't go to the same passenger, but also that every passenger does get picked up when they are in need of the man lift. After that, we have set and shine, which include setting the whiteboard and radio in a set location and properly maintaining the lift environment. Next is standardization, which is covered in the SOPs we talked about before. And the SOPs will also ensure not only a standardized process that every operator follows, but also a sustained procedure for the man lifts. And our last S is safety, which is not always included in 5S, but we thought it was vital to include because safety is a top priority in construction environments. And the set standard operating procedure should always keep safety in mind for all the processes that it has the man lift operators go through. And after that, another one of our ideas for improvements to the current system is the idea of lift scheduling or floor designation. So currently, Webcor already has one man lift work as an express car first thing in the morning around 7 to 7:15, and this essentially starts at the ground floor, and everything that's loaded onto it are materials, and those are sent straight to the top floor without stopping. Additionally, a new thing to implement would be assigning each lift to a specific zone, such as assigning one lift to the bottom 10 floors, one lift to the middle 10 floors, and one lift to the top 4 or 5 floors. And this would prevent each lift from traveling the distance of the entire building over and over again, when not all 3 of them need to be stopping at every possible floor in the building. And after that, since most Webcor work is done on the top 3 or 4 floors, dedicating one car to go to the very top floors without stopping would ensure that a lot of the Webcor employees who are working on the top few floors are able to get up there as quickly as possible.
Okay, so we used an elevator simulator that we found online in order to get an idea of the results that certain alternatives would bring. Because the man lift is basically a temporary elevator with manual operations, the elevator simulation would give us pretty similar results. We only used the simulator to illustrate the flow of workers that happens not during peak hours, so this isn't supposed to simulate the morning rush or before the end of the day when everyone is leaving. And to get an idea of how the number of elevators in the system would affect the results, we kept all the other inputs constant. We used our collected data as inputs, such as 40 seconds for workers to get on the elevator, and then about 100 people on the job site at one time, and about 10 floors being accessed at one time. And the simulator followed kind of what we expected for having an additional elevator. There were lower wait times, as you can see, a lower number of stops, and the distance traveled was about the same, and the travel times were pretty similar as well. However, because the simulator doesn't account for a lot of the variability and factors that happen on the job site realistically, we wanted just to use it as a tool to give us a general idea of the elevator system.
Through multiple discussions with Webcor, we've established some average costs that go into renting and maintaining the man lifts. Some examples of these costs include installment, floor jumping, testing, and other rental costs. Here we can see the cost variance between the three scenarios, in which 3 man lifts is their current setup. The difference between a dual man lift and a single man lift is that a dual man lift tower mast holds 2 cars on one shaft, while a single mast holds 1 car on one shaft. In terms of cost, the dual mast is cheaper than 2 single masts. From our calculations, having 2 man lifts is about $250,000 cheaper than the current, and having 4 man lifts is about $200,000 more expensive. So for results, we want to talk about the benefits to their current system. A benefit to it is that there is little training required, since the employees are already trained to the current situation, and the only thing they would have to learn is the SOPs that we want to present them. At the same time, all costs will also be the same. If we take 1 man lift away, we lower the overall costs of the man lifts by about $250,000. This scenario would best fit for smaller buildings, as less workers are expected on a smaller job site. And with 1 less man lift, you allow for less confusion between the operators when they're communicating with each other, or to the employees calling for the lift. With the situation of 4 lifts, we get the benefit of increased productivity, where wait time for employees is minimal, and in turn reduces the need for overtime while adding more time value. In conclusion, we wanted to briefly go over our overall recommendations. We want to propose an SOP to Webcor that highlights the usage of a whiteboard, which will reduce confusion of the operator when determining floor calls. Our procedure will also remind employees to have an efficiency mindset by taking ladders so that they can reduce the wait time for other employees on the lift. We also would like to provide different cost situations dealing with the number of lifts on the site, and from here Webcor can decide if they value more or less man lifts with the cost in mind. The final recommendation is to propose lift scheduling concepts to Webcor. The goal of the zones is to assign each lift to a designated floor range. We also want to encourage the idea of an express car traveling to the top floors for a short period in the morning to get equipment up to the top floor, as concrete pouring is the initial step in building the structure. And thanks for watching.